Hello, ladies and gentlemen. So now we're going to graph the secant of theta. Okay. So, so the first thing I want to do before we graph the secant of theta is I want to know what the secant of theta is. So by definition, the secant of theta is equal to 1 over the cosine of theta. Okay. And so again, just as in the graph of the cosecant of theta, we can see that there's going to be a close relationship, at least in some portions, uh, with the behavior of this function and the behavior of the 1 over x we introduced to it, right? And if you want, you can pause right now and you can try to mimic the analysis I did for the cosecant of theta and see if you can discover the graph of the secant of theta on your own, okay? With your knowledge of the cosine theta. So if you want, you can pause now and do that, or if you want, you can continue and watch this explanation. Either way is fine. Anyway, so now let's continue. So first of all, let us draw the cosine of theta on our graph paper. So this is our x, this is our y, and let's say this is 0. Let's say this is pi over 2 pi 3 pi over 2 and 2 pi. And we know that as we're going in this direction, what we're doing is we're wrapping around the unit circle counterclockwise, starting with 0 as your angle, as your starting angle on the right-hand side of the unit circle. And we also remember that the cosine of theta, when we're thinking about a unit circle, the cosine of theta is the x-coordinate of the point. So at 0, it starts at 1. Then at pi over 2, it's at 0. The cosine. At pi, it's -1. Then it's 0 at 3 pi over 2. And it's 1 again at 2 pi. And of course, that's one period. We've gone around the circle once. So when we continue going around the circle as we populate the larger x values, this pattern that we see will continue. And of course, the graph cosine is very delicate, just like the sine is, in terms of the way it curves. Okay. Now, by the way, you might say to me, well, David, and of course you could probably say this about a lot of the graphs we're doing. David, we have technology. We can graph the graphs perfectly. Why would you even think about wanting us to graph them by hand like this, going through all this effort? Part of it is developing intuition, and part of it is understanding how to do it, and part of it is when you need to do the calculation. If you know how to do it by hand, it can help a lot. Okay, and of course, if we do some example, and of course, later on, you'll see that. But anyway, I think it's a great skill to have. Okay, especially if you want to study math or something like that, it's a great skill to have. Anyway, let's continue. So we see that this is our cosine graph. Okay. So now we can start to investigate what this tells us. Okay. What I'm going to do here, just like I did before, is I'm going to make a little table here of some important values. Right. So this is our theta. This is going to be our secant of theta, aka 1 over the cosine theta. The easy ones are easy to see. So if theta equals 0, the cosine of theta is +1. And so what's 1 divided by +1? That's just 1. So if I'm at theta equals 0, the secant of theta is 1. Similarly, at pi, the cosine of theta is -1. So at pi, 1 divided by -1 will just be -1, right? And from what you can see here, you can see that at let me see this here. You can see that at 2 pi, right, the cosine of theta is 1. So again, 1 divided by 1 is 1. So at 2 pi, the secant of theta is also 1. The behavior that's interesting, let's say interesting, is going to be the behavior near pi over 2 and 3 pi over 2, because that's where the cosine crosses the 0, right? Now look at it this way. At this point, as we come toward pi over 2 from the left, the cosine of theta values are all positive. See, they're all above the x-axis. And if we take 1 and we divide it by a positive number, we get a positive number. But since the cosine values are approaching 0, right? See, because here, for example, here, cosine of theta is 1. Here, the cosine of theta is square root of 3 over 2. That's a power over 6. Here, the cosine of theta is square root of 2 over 2 at pi over 4. Here, the cosine of theta is 1/2 at pi over 6. And it's 0 at pi over 2, right? So as we approach pi over 2 from the left, the cosine values are decreasing and they're decreasing towards 0. But they're all positive. And so what does that mean? We're going to have 1 divided by a positive number that is getting closer and closer to 0. So that means, in analogy with what we saw before, that this is gonna go to positive infinity here, right? So we can draw our asymptote here. I'm gonna draw it again with a dotted line, and so it'll look like this, something like that. Okay, that's and by the same reasoning, as we come to pi over 2 from the right, here the cosine values are all negative. And so that means we're going to have a positive number divided by a negative number. That's going to be a negative overall. And since the bottom is getting closer and closer to 0, it's going to get very large negative, right? And so here we have an asymptote. And here also, you can see we're going to have an asymptote because we're going to see the same kind of behavior, right? See, as we approach 3 pi over 2 from the left, look at the cosine values. They're all negative, right? And so that means that we're going to have 1 divided by a negative number, which means that the result will be negative. But since the cosine theta values are going to 0 as we go towards 3 pi over 2 from the left, that means that we're going to have 1 divided by a negative number that's getting closer to 0, which means that the values will go to infinity, go to negative infinity, right? Finally, you can see here, oops, not here, I'm sorry. As we approach from this direction, the cosine values are all positive, but they're going to 0. So we're going to have a positive divided by a positive. So it's going to be positive. And we're going to have the asymptote like this. Okay? So now, what we can do, right, is we can erase our cosine graph, right? Because we don't need it anymore. We can think of our cosine graph as kind of like a scaffold. We put it there to draw our graph of our secant, and then we delete it once the graph of our secant is gone. Once the graph of our secant is drawn, right? So now we're left with one period of the secant. And again, because we know that that was one complete period of the cosine, we know that this pattern is going to continue that way and is going to continue this way. So for example, here, we know that that's going to have the asymptote like that. And we know that this is going to be over here. Okay. Oops. And of course here it's going to go like this. And it's going to continue this way and that, like that. Okay. One of the main important things I want you to notice about the way we graphed right now the cosecant of theta and the secant of theta is the way I want you guys to think about how the numbers are behaving, and the basic how the numbers are behaving. See, we're not just going off of rote that there's an asymptote here or there's an asymptote here. We're thinking about what the numbers are doing so that we can get an intuition for, it should go up like this or it should go down like this. That way, in the moment, you can always recover what the graph looks like. And again, just as with the cosecant of theta, my advice to you whenever you're graphing a secant of theta is to first draw the cosine part, of course, very delicately with very lightly shaded pencil, so it'll be easy to erase. Draw in your secant graph, and then erase the cosine function, leaving you with the secant graph that you like. Anyway, thank you so much, and I hope this helped. You're still there? You're watching this video? Well, I hope you enjoyed it. In any case, if you did enjoy it, well, I encourage you to like it. Put that big thumbs up there. And don't hesitate and don't forget to subscribe to my channel. And anyway, and also add a comment if you want me to cover some particular topic. I can't make any promises. There's a huge list of topics I already want to cover, but time permitting, I may address that topic. And in any case, I hope you've enjoyed this video, and thank you again.